So we're looking at question 7 in our tutorial book. Consider the following graphs. So we've got graph B, C, D, E, and A. Okay. Which, if any, represent direct proportionality? Okay. So what I'm going to do is I'm going to pull up my GeoGebra Classic 6, which I'm all expecting you to have loaded on your laptop computers, either in the Windows version or, like mine, the Macintosh version. Here we have GeoGebra. So what I'm going to do is I'm going to click on this one here. This is the thing for a slider. I'm here for the slider, and I'm going to click on there for my position. Slider A is going to go. It's going to be a number from -5 to 5. Increment 0.1. I hit OK. Okay, so this just gives me a slider. As I slide this backwards and forwards, the number varies. So now what I'm going to do is I'm going to put in here, in this input here, in the y equals a times x. Enter. Okay. So as I change this, you can see. Okay, so now the definition of proportionality is if x and y are proportional, then we make them equal by putting in a constant. Now, as we vary this constant, you can see the slope changes. It's always going through the origin. Now, look what happens when this constant becomes negative. Voila. Okay, so this is this negative slope is also directly proportional, but it's negatively proportional. It's a form of directly proportional. So what I'll do is I'll minimize this. So going back to this question, which, if any, represent direct proportionality? Okay, so it's got to go through the origin. So there's only two that go through the origin. D. Okay, this has a positive direct proportionality. E is also directly proportional, but it's a negative coefficient of proportionality, but it is still coefficient. So this A value here, we often use alpha, but I've just called A. This is the constant. So the constant can be negative. Okay, it must always go through the origin, and it produces a straight line. Okay, so for A, D, and E represent direct proportionality. B, which, if any, represent a linear relationship which is not directly proportional? Okay, well, linear relationship just means it produces a straight line. Okay, so A is producing a straight line, and C is producing a straight line. Okay, so again, what I can do is I can recreate a line like this on our GeoGebra. Okay, so again, I'll put in another slider. This time I'll put it below here. We're going to call it B. Yep, and we'll let it increment 0.1. Okay. And then I'll come back to here, and I'll go plus B. Enter. Okay, so what's happening here? This will only be directly proportional when our B value is 0. Okay. So here we've got this here. We might change this slope or whatever like that. Okay. So this line here is looking very similar to C, isn't it? Okay, but it's a linear. It's a line. Then we had one where if I change this to negative, it's negative slope, it goes like this. And what does it look like? There we are, yep. A looking like A, yep. So again, this is being generated by this function here, but it's okay. Let's minimize this. Okay, and then we'll come up to here. Now, okay, so we've settled for B that that C and A are linear relationships which are not directly proportional because they have a y-intercept, which, if any, could represent inverse proportionality. Okay, so what I might do, inverse proportionality, we could go y is equal to A times, A divided by X. There we are. Okay, enter. Now, what I might do is I'll turn off this line here. I can do that by switching this off. Cancel. Okay, so now what I can do is I can change this A value. It's going very negative. Then, okay, when it crosses over from 0, it's a straight line, but then, okay, so we've got something like this, okay? Can you see? Let's get our curve up here that we're looking for. Where's our curve? We had something that looks like that, okay? There could quite possibly be another curve on the other side, but we have just generated that, okay? See, okay, so there's no B value in that, okay? So this slider is not affecting that at all, okay? So this one here, we've generated a curve that looks very similar to that, and this is y times our constant, our alpha constant, over x, which is 1 over x is that's our inversely proportionality. So we can safely say that B is inversely proportional.